Hello. In this video, we are going to replicate the second table, table 2.2.2. This table is based on linear regression analysis. And let's have a look. There are 4 columns, and each column has each column is one regression estimation, and their difference is in the explanatory variable. So remember, regression model is like y equals to x something, or like beta x2, something like that. And then y on the left hand side is called dependent variable. In this case, in the note, it says the dependent variable is the Stanford Achievement Test percentile score. So y variable is percentile score for all the for all 4 regressions, and their difference is in their explanatory variables. In the first regression, only 2 variables are used, small and aid, as the explanatory variable. Fixed effects is not included, and R square is a result of the estimation. And in the second regression, the explanatory variables are the same, but additionally, school fixed effects are included. I will show you how to implement that. And in 3 and 4, more variables are included. So that extension is straightforward. And the number is the coefficient, estimated slope of respective variable. And in the parentheses is the standard error. So here it says standard error. And the sample size is 5,681. So let's implement this. It's a linear regression, which is very important. And linear regression is here. Linear models, linear regression. Click this. And actually, I have been trying this. And you choose dependent variable. Remember, dependent variable was test score. And independent variable, the explanatory variable is small and aid, right? So actually, I changed some options. And we click that. If you click that, then you get this. By the way, I ignore the upside. Here, this is the result we just obtained. So the command is regress a dependent variable p-score on small and aid. That is the command we just implemented. And in this result, let's see, some sample size is 5,874. I don't know where the difference is coming from. As you see, it's different from this number, so I have no idea why it's different. Somewhere something was not explained in the textbook. But anyhow, the difference is small. And R squared, this is what you see from the table in the last line. So this captures the percentage of explained part in the dependent variable. So it means that this regression model explains only 0.67% of test score, which is rounded to 0.01. And this is the estimated coefficient of small, this is the estimated coefficient of aid, and this is the intercept. And this means constant. So this is the coefficient of constant, which is intercept. Anyhow, we don't need the intercept. We just need these 2 numbers. And you see 4.82, 0.12. Not exactly the same, but difference is pretty small. And and the standard errors are quite different. The difference is coming from, this technique. So in the table, they use some additional options to calculate the standard errors. But we are not going to discuss that option. we will study that option later. Later in homework 3 or 4, you are going to learn how to implement that. Anyhow, this is the coefficient, this is the standard error. So you have to copy those numbers and make your own table that look like the textbook, and the numbers will be different now. So this is regression number 1, the first column, and in the second column we do the same thing, but the difference is school fixed effects. Remember, we have school identification variable. So summarize this variable, school identification kindergarten, right? So there are 80 schools in our data. So in theory, in practice, in principle, we have to include 80 different dummy variables, which is very inefficient if we have to generate them. But Stata can do it easily using PS core small a. So far, I'm using the same command, but I want to include this variable, but by redefining it as many dummy variables. To do that, I put I dot. If you use I dot variable, that means then this guy will be included as a dummy variable for each value of that. So let's try this. Then this is the result. So there are school number 1, school number 2, school number 3, and the data automatically calculates up to school 80. By the way, school number 1 is missing because we need one reference group. Last time, in the last class, I explained when there are 3 different values, like class type, we need 2 dummy variables. Similarly, when you have 80 schools, you need 79 dummy variables. But the school number 1 will take 0 for all the dummy variables. So the program automatically understands what's going on. So anyhow, we do not need to read them. It's not of our interest. I don't know which school is what. But what's more important is these coefficients. You can read it in the same way. Number of observations, the same, right? And look at this. R squared increased a lot. Now, by including the school differences, we improved our explanation power from less than 1% up to nearly 25%. So school explains a lot. So that means there are a lot of unobserved characteristics of the school, like school quality, school district, and I don't know. So the peer effect, the atmosphere in the school. So things like them are very important in test score. So it explains a lot. And also the estimated coefficient, change it. Still they are similar but a little different from these guys. And standard errors also recalculated. They are different. So you make another table. You make the second column out of this table. So the idea is I dot school identification. So this includes the school fixed effects, and the other regressions are pretty automatic. Now, by the way, the regress command can be shortened to reg, p-score small a, and the variables we needed was, let me put it aside and copy it. We need white Asian girl, free lunch, a white teacher, And let's click from here. Teacher and teacher experience. I have to find it from here. Total experience, kindergarten, and master. And I dot school identification. Right? Oh, excuse me. It's my bad. In the third regression, we do not need these guys. So this is the third regression. Column 3. We additionally include white Asian and girl and free lunch. And compare the numbers. Those we just did the number 3, column number 3, and it explained 31% of test score, and numbers do not change much. So these numbers do not change much. Also, these numbers do not change much. So up to after the school fixed effect, additional variables have a little bit of explanation power, but not much. That is, by the way, this is powerful. So free lunch is powerful, but anyhow, it has nothing to do. It does not affect, does not change these coefficients. So that is what we learned. And finally, in the same way, include all the variables. Then you get the last column. The last column includes more variables about teachers. White teacher, teacher experience, master degree. So then we implemented 4 different regressions, and you have to collect the appropriate results from each regression and make a table like what you see in the textbook. That is homework number 2. And in the next video, I am going to show you how to make a do-file. So actually, I had to explain that earlier. You better use do-file from the beginning. And I want you to write down a do-file by yourself. Okay, see you in the next video. I will summarize what you have done and make a do-file out of that.